Hey guys, welcome to my YouTube channel. I'll be solving LeetCode 75 list using Golang. So let's look at today's question, maximum consecutive ones. Given a binary array nums and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. Okay, so let's go to the drawing board and understand the question. So we are given a binary array. So binary array means an array with ones and zeros, and then we are also given a k. So k means you can flip at most k zeros in this binary array, and you need to find a subarray which has maximum number of consecutive ones. For example, in this array, if you see, so you have currently what is the maximum number of consecutive ones here? Three ones are there consecutively, one after the other. Now they have told you can maximum flip two more zeros into one. So these two zeros, I will flip them to one and include it in the same window. So now what's the maximum number of one? 1, 2, 3, 4, 5. 5 is the maximum number of one. But is this maximum? No, because consider this window. So let's get rid of this. Consider this window. You have four ones plus include this 4, 5, 6. Okay. Now what is the size of the window? Size of the window is 6. So this window you can consider, and this is the maximum size of consecutive window. And also make sure that you use only two zeros at max because k is 2. So we only made use of two extra zeros to get this. Now I'll assume you'll understand you understood the question. So let's look into the brute force logic of how we would solve this. So brute force, I think doing this brute force is more difficult than the actual doing it in the optimal way itself, because there is no straightforward brute force solution. So how would you do it? So one thing is to traverse all possible subarrays, and then you need to make sure, let's say your subarray, when you're traversing all possible subarray, that will cost you O of n square time complexity. So let's say one of the subarray when you are traversing was 1 1 1 0 0. So one of your subarray was like this. So if a subarray consists of zeros, so count the number of zeros. So number of zeros is 2. So if count is less than or equal to k, then you should record the length of that subarray. Otherwise you can't record the length of that subarray. So regardless, that will cost you O of n square time complexity. Okay, so I hope you understood the brute force solution. So basically traverse all possible subarrays and consider the subarrays where count of zeros is less than or equal to k, and maintain like a global res and keep updating it, obviously. So this will cost you O of n square time complexity. Now let's see how we can optimize this. Let's erase this up. So to solve this, we'll use something called as, we'll use uh, we'll use the technique, sorry, having some issues with the pen. We'll use the technique called as sliding window. So if you've seen my previous window, you would have understood what a sliding window technique is. It's basically like if you have an array where x can be anything, like it can be a character, number, anything, we'll consider basically a window, and we'll keep like sort of extending the window and sort of moving, basically sliding the window, like keep sliding the window. The window size will be of something like k in size, and then while sliding this window we will do some objective that will be given in the question. So this is just a vague and high level description of what sliding window does in general. Specific to this problem, I'll explain you like in detail how it will work. So for this specific problem, let's see how we will employ sliding window. So yeah, so let's see. Basically, have your L and R here initially, everything pointing to the first location. Keep moving your R. R is here, which is 1, 1. Then we encountered 0. We encountered 0. So we know maximum 2 zeros are fine. So this 0 is still fine. So keep extending the window. Now one more 0 we encountered. That is also fine. Keep extending the window. And then one more 0 came, but this is not fine because maximum we can have 2 zeros. We already had these 2 zeros. Now one more 0 came. So this window is not no longer possible. So basically the maximum window that was possible is only till this. So, and whenever you keep moving this window, keep recording the size also. So as and when you are moving R, keep recording the size. So size of the window is given by R minus L plus 1. If you do this, you will get the size of the window. Keep recording this. So at this point, the size of the window will be 1, 2, 3, 4, 5. 5. So maximum you will have like a global res, which is 5 for now. And then now is the interesting part. So let me rewrite this. L was here and R was here at this 0, which was invalid. Now what should we do with this L? We need to move this L so that the window is valid again. Window will be valid only when the count of zeros is k. So currently there are 3 zeros. So the window will be valid only when the count of zeros is 2. So you need to move this L to a position where it surpasses one of the zeros. So basically, which is the first 0 when you are moving like this. So let me do it in a different color. Yeah, when you are going like this, what is the first 0? So this is the position of the first 0. So you need to move your L one position after it. So your L will be here. So why we did this? Why did we bring our L from here to here? Because of this 0, the count of zeros was 3. Now if you surpass this 0, uh, the count of zeros will be 2. That's why we moved our L so that we can surpass this 0. I hope you understood that logic. Now our window is again clear. We only have 2 zeros. Okay, and keep recording the rest. Rest is the size of the window is 2 here, but we already have 5. So let's not it won't get updated. So keep moving your R. It's 1 means you can just keep moving. So your window will move till this point uh, where it is 1, but okay, there are 2 zeros, so we can still move it. So when you move here, now we have 3 zeros. So remember, where was your L? Your L was here. Your L was here and your R is here. So now how many zeros we have? 1, 2, 1, 2, 3 zeros. It is invalid. So again you need to move your L 1 0 uh, 1 0 after the previous L, because you want the number of zeros to be equal to k. So our L will be moved here. Now what is the size of this window? If you will do R minus L plus 1, what is the size of the window? 1, 2, 3, 4, 5, 6. 6 is greater than 5, update it to 6. So final rest will be 6. So I hope you understood the logic. Sorry for having too much stuff on the drawing board. It might have confused you guys, but basically, like what you have to do in simple words, uh, the window is valid only if there are two zeros in that window. Okay, so let me just revise it. So if you consider this, if you consider this L 1 2 3 4 5, okay. So here in this window, if you see, I'll zoom it out here. 1 1 1 0 0. This window is valid. Okay, this window is valid because we only have two zeros. Now, when your R basically moves here, when your R moves here and your L is at the beginning, now we have three zeros in the window. So the window is no longer valid. So you need to move your L so that you surpass one of the zeros. Why you need to surpass one of the zeros? So when you surpass it, you will only have two zeros. That way you will maintain the condition the k is equal to 2. So we'll move this L here. That's basically the entire logic of this question. I hope I made it clear. Now let's go back to the editor and write the code. Yeah, so the code is again quite simple if you have understood the logic. Have a res, have a count. This is nothing but current number of zeros in the current window. Okay, L will be equal to 0 and R is equal to 0. R is less than len of nums and R plus plus. Okay, now if nums of R is equal to 0, count plus plus, increment the count, and then if count becomes greater than k, only there should only be k zeros. So if the number of zeros becomes greater than k, what did I tell? You need to move your L. So while, sorry, Go doesn't have while. So for nums of L not equal to 0, L plus plus. So now after this loop, L will be pointing to a 0. And as I mentioned in the explanation, you need to surpass the 0. So L plus plus again and decrement the count because the number of zeros just reduced by 1 because we surpassed the 0. Number of 0 reduced by 1, decrement the count. Now record the size of the window. So if count is equal to k. So basically if we have exactly k zeros, or we don't even need to have exactly k zeros. Even if we have like k or lesser than k zeros, we can just record the size. So res is equal to max of res comma r minus l plus 1. R minus l plus 1 gives you the size of the window. Recorded it and return the, yeah, run this. Mm, 31%. I don't think this is correct because it's the optimal solution. Yeah, the editor sometimes doesn't give the right runtime. So what is the time complexity? Time complexity is O of n because there's only one loop, so it's O of n, and space is O of 1. That's why I was mentioning this is the most optimal solution, because we have time complexity of O of n and space complexity of O of 1. Thank you so much for watching my YouTube video, and please stay tuned to more such problems, and please subscribe to my YouTube channel.